Now that we know a wire carrying a current I, when placed in an external magnetic field B, experiences a force, and that force is equal to IL cross B, the next question is, what happens if we have two wires, each carrying a current I, placed near each other? Before getting to that question, though, let's take a closer look at this new equation, IL cross B. To find the magnitude of this force, we do what we always do with cross products, where the magnitude is the magnitude of the first vector times the magnitude of the second times sine of the angle between them. So this is our magnitude of the force. The direction is given by our right-hand rule for cross products. So let's practice that now. Here are some examples. In the first example, suppose we have a wire with some current I up the page, and it's placed in some magnetic field B that is directed to the right. In example 2, suppose we have some wire carrying a current into the page, and that wire is placed in a magnetic field that is directed down the page. And in the third example, suppose we have a wire carrying a current I to the left, and that wire is placed in a magnetic field also directed to the left. What I'd like you to do is pause this video and use your right-hand rule for cross products to determine the direction of the magnetic force in each of these examples. Using the right-hand rule for cross product, we find that the magnetic force on a wire with current directed up the page placed in a magnetic field directed to the right is into the page. In example 2, if the current is directed into the page and the magnetic field is down, the right-hand rule for cross products tells us that the magnetic force is directed to the left, and in the last example, the magnetic force is actually equal to 0. The reason is because our current, and therefore our length vector, are to the left, which is in the same direction as our magnetic field direction. And so the angle between those two vectors is 0, and sine of 0 gives us 0.